Newton's first law states that when the resultant force acting on an object is zero, a stationary object will remain stationary. For example, if we have a plant pot on a table, then the first force acting on it is its weight, which is directed downwards. And then there'll also be a reaction force from the table as it pushes back against the pot, and this force is directed upwards. Remember that the resultant force on an object is the single vector with the same effect as the other forces combined. Let's suppose both of these forces have the same magnitude of 50 newtons. Then the forces are equal and opposite and cancel each other out. This means the resultant force would be zero. The plant isn't moving, so Newton's first law tells us that the plant still doesn't move. It won't suddenly fall through the table or rise off it. This is only the first part of Newton's first law, though. It also tells us what happens to an object that's already moving. A moving object will continue to do so with the same velocity. So in full, Newton's first law states that when there is no resultant force acting on an object, it will either remain stationary or continue to move with the same velocity. You may be asked to state any of Newton's 3 laws in an exam, so practice writing this down from memory. Let's understand this part of the law better. Suppose we have someone moving forward on a mobility scooter. Remember that we use the term velocity to describe what direction someone is moving in and how quickly they're moving. So we can say that this person's velocity is directed forwards and has a certain magnitude or speed. Again, we should look at the forces at play here. The scooter provides a driving force directed forwards, and there will also be friction, a resistive force in the opposite direction. If both of these forces have the same magnitude, let's say 100 newtons, then we'll again have a resultant of zero. This time, Newton's first law tells us that the scooter will have a constant velocity, as it's already moving. This means that the scooter will continue to travel at the same speed and direction. A very common mistake students make in exams is thinking that Newton's first law wouldn't apply here and that it's only for stationary objects. Make sure you understand both cases where the law applies. So now we know how to keep an object stationary or travelling with constant velocity. But what do we need to do if we want to change this motion? Well, an object's velocity can only change when there is a resultant force acting on it. So in our scooter example, we need to change the resultant force, and we can do this by changing the driving force, which will change the velocity. We can increase this force to get a forward resultant force and accelerate, or decrease the driving force to get a backward resultant and decelerate. Now let's have a look at a few more situations where Newton's first law would apply. Newton's first law can apply to objects where the forces acting on them are balanced or where no forces act at all. It's important to note that when we say that the forces are balanced, we mean they are balanced in all directions. For example, if we consider a plane flying through the sky, there will be 4 forces acting on it. We'll have an upward lift force from the wings, a downward weight due to gravity, a forward driving force from the engine, and a backward drag force from moving through air. Here, Newton's first law will only apply if the weight balances the lift and the driving force balances the drag. If either pair isn't balanced, then Newton's first law won't hold and the plane will speed up, slow down, or change direction. Now let's consider this example of a space shuttle. There's no gravity to cause weight and no air to cause lift or drag. If we have the engine switched off as well, removing the driving force, then there will be no forces acting on the shuttle at all. Since there's no forces, there can be no resultant force. So Newton's first law still holds for this case. The shuttle will either stay still or drift in space with a constant velocity. You don't need to know these exact examples, but make sure you can identify how a given example demonstrates Newton's first law in an exam.
Thanks for watching. If you want to take your GCSE revision to the next level, head over to launchpadlearning.com and check out our smart learning platform that's been designed to get you top results in your exams. We cover your whole specification and make revision fun with interactive quizzes, easy-to-follow videos, and more. You'll be kept motivated by your own AI tutor who's here to support you every step of the way. To check it out for yourself, click here. Or click here to keep watching a selection of the videos from our full GCSE Physics course. See you there!